Okay, so let's take a look at 4.4, the nature of roots. And let's just remind ourselves yesterday's homework when we were doing the quadratic formula. And there were a couple examples in the quadratic formula because remember what types of roots you can have. Okay, because sometimes you end up with two roots or two x-intercepts. Sometimes you only end up with one x-intercept. And sometimes you end up with no x-intercepts. So just remember this part of the quadratic formula is the most important part when you're talking about how many solutions there are in a problem or how many x-intercepts there are in a problem. And this b squared minus 4ac, the number underneath the square root sign of the quadratic formula, is called the discriminant. Okay, so if we ever refer to this word discriminant, we are talking about the quadratic formula and the number underneath the square root sign, because that's very important when dealing with what kinds of roots there are, or what kinds of solutions there are. So let's take a look at this. If this discriminant, b squared minus 4ac, if the equation has two real solutions or two x-intercepts, okay, and it says function has two x-intercepts, this number will be greater than 0. Okay, so if you have any positive number underneath that square root sign like you saw in your homework, what will end up happening is that the parabola will cross two times. You will end up with two solutions. Now, are the solutions nice or not? That doesn't matter, but you end up with two solutions. If this discriminant is equal to 0, and this I spoke about in class, if that number underneath the square root sign is equal to 0, what will happen is you will only get one answer. So in order to get one answer, that means the vertex is your x-intercept. You only have one answer. And lastly, if this discriminant, if that number underneath the square root sign is any number less than 0, meaning a negative number, if it's a negative number, and remember in your homework, if you had a negative number under there, you couldn't continue the problem any further because you cannot take the square root of a negative number. So what does that mean? That means that there are no answers. So something like this could be happening where you have a parabola that is opening up, but it does not cross the x-axis. So there are no solutions. Okay? So it says in order to figure out how many real solutions a quadratic equation has, or how many x-intercepts that this has without solving, all you're going to do is just use the discriminant. So maybe a question doesn't ask you what the x-intercepts are, it just asks you how many x-intercepts are there. So let's look at the example. Determine the number of real solutions of each quadratic equation without solving. So I don't want you to actually solve, I just want to know how many solutions there are. So if we look at the first one, example A, it says x squared minus 30x plus 225 is equal to 0. Remember that the formula has to be in standard form in order for you to use the quadratic formula. This already is in standard form, so we're good. Now my a value is the number in front of the x squared, which is 1. My b value is the number in front of the x, which is negative 30. And my c value is the number that is all alone, the constant value, which is 225. And so in order to figure out how many solutions this thing has, all I'm going to do is not actually figure them out. All I'm going to do is use the discriminant. Now the discriminant is just the number that's underneath the square root sign, which is b squared minus 4ac, the number underneath the square root sign of the quadratic formula. So plugging this in, I end up getting b squared, which is negative 30, all of that squared, minus 4 times a is 1, times c, which is 225. And then if I do this on a calculator, negative 30 squared is going to give me positive 900. And if I do negative 4 times 1 times 225, that's going to give me negative 900. And 900 minus 900 is 0. So if b squared minus 4ac is equal to 0, just remember that means that there is only one real solution. So there's only one x-intercept. Okay? doesn't ask me for what the x-intercepts are, it just asks me how many x-intercepts are there. In that case, there's only one x-intercept. Let's take a look at the second one. How many x-intercepts does this thing have? Again, my a value, this is in standard form, so we're okay. My a value is 3, my b value is 2, and my c value is 15. So now, all I'm going to do is use the discriminant to figure out how many solutions this has. Okay, it doesn't ask me to find them. If it asks me to find them, of course, I can either factor or I can use the entire quadratic formula, but it just asks me for how many. So this is equal to b, which is 2 all squared, minus 4 times a, which is 3, times c, which is 15. If I do 2 squared, it's going to give me 4. And then I'm going to have negative 4 times 3 times 15. So negative 4 times 15 is negative 60, times 3 is negative 180. And 4 minus 180 is negative 176. So if b squared minus 4ac is equal to negative 176, if this is ever equal to a number less than 0, any negative number, the equation will have no solutions, because remember, if the number underneath the square root sign of the quadratic formula is negative, you cannot take the square root of a negative number. So this would end up having no x-intercepts. Okay, so no x-intercepts is the answer there. Let's take a look at the last one. The last one has 2x squared minus 5x minus 1, and this is in standard form. Remember, if it's not in standard form, you have to first put it in standard form. My a value in this case is 2, my b value is negative 5, and my c value is negative 1. Now, using my discriminant, because it's asking me to figure out how many solutions, this is going to be b, which is negative 5, all squared, minus 4 times a, which is 2, times c, which is negative 1. So I end up with negative 5 squared is positive 25. Negative 4 times 2 is negative 8, times negative 1 is positive 8. And of course, 25 plus 8 is 33. So b squared minus 4ac in this case is a number that is bigger than 0. And if you have the discriminant bigger than 0, that means there will be 2 x-intercepts. So there are 2 x-intercepts in this case. Okay. Now, again, if the question asks me to solve, I would have to use the entire equation of the quadratic equation here, or I can solve by factoring and then finding the zeros. But if it is asking me for how many zeros there are, all I have to do is use the number that's underneath the square root sign, otherwise known as the discriminant. And if the discriminant, again, is a number bigger than 0, you have 2 x-intercepts, which will look like this. If it's equal to 0, you will only have 1 x-intercept, which will be the vertex. And if it's less than 0, obviously it does not pass through the x-axis. It looks like this. Okay? So my suggestion to you is actually do some of the problems from today's homework. So if I look at 4.4, page 232, I would try to do questions 2, 4, and 5, or maybe questions 2 and 4, and then that means there's less work for you tomorrow during the class.